Welcome to the 3.2 notes, greatest common factors, or GCFs as we're going to call them. What we're going to be talking about here is the greatest factor that two numbers have in common. Greatest means biggest, common means they share it, and factor is something that you can divide by. Before we get super far into it, let's start with an example of why this might be useful. So Mrs. Enneking is dividing the choir up into small groups. There are 24 sopranos, 60 altos, and 36 tenors. Each type of voice needs to be divided evenly. What is the greatest number of groups that she can form? So we want the biggest number that we could use. So what we're going to do is take the numbers for each section and find their factors. So for example, 24 is 1 and 24. Don't forget the 1. Or 24 divided by 2 is 12. So I could do 2 times 12. Or 24 divided by 3 is 8. So I could do 3 times 8. Or 24 divided by 4 is 6, so I could do 4 and 6. So the sopranos could be split up into 1 group, 2 groups, 3 groups, 4 groups, 6 groups, 8 groups, 12 groups, 24 groups. We want the most number of groups, not necessarily the most number of sopranos in each group. And then I have to do the same thing with 60. You might have to write a little bit smaller to get 60 to fit in there, because I'm going to warn you there are a lot of numbers that go into 60, like 1 times 60, or 60 divided by 2 is 30, 60 divided by 3 is 20, 60 divided by 4 is 15, 60 divided by 5 is 12, and 60 divided by 6 is 10. I know I'm done with my list because 7, 8, and 9 don't go into 60, and those are the only 3 numbers in between 6 and 10. And then we do the same thing with 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. So I'm only going to write the 6 once, because I don't need to write 6 twice. I'm just looking for how many different numbers go into each one. Okay, now I need to try and narrow down until I see the biggest number that's on all 3 lists. Well, I can go ahead and cross out if I would like 60 and 30 and 20, because I don't see those on any other lists. I also don't see 15 on any other lists, but 12 is on all 3. So you just start with your biggest numbers available, and then you work your way down. Not start with the smallest and work your way up, because greatest means biggest. That's why I started with the biggest number, and I started with the biggest numbers on that list. So 12 is the biggest number of groups she can make. This section is a lot easier if you know your multiplication facts, so we will be practicing them in bell work all week long. All right, let's get into a little bit of vocab. You can just circle with me today. A common factor, the word common, means it's a factor of 2 or more numbers. So they share it. So I'm going to write shared next to it, because that's what common means. And then the next term is greatest common factor. That's just the biggest one. Greatest means biggest. I don't think there's anybody in here who doesn't know what greatest means. And then relatively prime. If two numbers do not have a greatest common factor, or if their greatest common factor is 1, that means relatively prime. Every set of numbers has a greatest common factor, even if it's 1. It just doesn't feel like it does if it's 1. And that's what we're going to practice today. So we are going to find the greatest common factor of each set of numbers below, and some of them you'll notice have some X's. We'll talk about that when we get down there. So what I want you to start with is, and it's listed right here, list all factors of each number and identify the greatest number that is on all lists. Sometimes there's 2 numbers, sometimes there's 3. So let's take 21 for example. 21 is 3 times 7. That's it, friends. 3 times 7. Except what I don't want you to forget is 1 and the number. And then I'm going to do the same thing for 42. 42 divided by 2 is 21. 42 divided by 3 is 14. And 42 divided by 4, nope. 42 divided by 5, nope. 42 divided by 6, 7. Okay, then just compare. What's the biggest number that we wrote twice? If you said 7, you were so close. But it's actually 21. And what I want you to do after you write the 21 is write GCF equals. If you just write 21, you're going to forget what 21 means. Okay, so GCF equals 21. And that's how you find the greatest common factor. Sometimes it takes a little bit longer if there's more factors of each number. Okay, there is a little bit of a shortcut, and I'm going to share it with you on this next one. On the next one, what I'm going to do is I'm going to pick 16, which is 1 times 16, or 2 times 8, or not 3, but 4 times 4. And then what I do is I try the biggest number, which is 16. 32 divided by 16 is 2. So since that's 2 and 16, that works. And then I try 40 divided by 16. Aw, man, it's a decimal. So that means that 16 is not my greatest common factor. So I try the next biggest number, 8. 32 divided by 8 is 4. So 4 times 8. And 40 divided by 8 is 5. So 8 does work because it is a factor of all 3. So instead of making a list for all 3 numbers, pick the smallest one and check its factors, biggest to smallest, to see if it works with the other 2. So on this one, the GCF would equal 8. Let's try that shortcut one more time because it can be a little tricky. 34. 1 times 34. 2 times 17. Not 3. Not 4. No, 5. No, 6. So I think that's it. 1 and 34 or 2 and 17, which means I have to try and divide 55 divided by 34. Nope. 55 divided by 17. Nope. 55 divided by 2. Nope. So the only number left is 1. And since the greatest common factor equals 1, that would be relatively prime. Relatively means that how they relate to each other, which means that their relationship is prime. There's nothing they share except for the number 1. Okay, I'm going to do D, and I want you guys to try E and F on your own afterwards. So, D, take the smallest number, 1 times 24, or 24 divided by 2, 2 times 12, 24 divided by 3, 3 times 8, 24 divided by 4, 4 times 6, and 24 divided by 5 doesn't work, and I'd be back to 6, which is already on my list. Then you go through and individually check all of these with 45. 45 divided by 24, nope. 45 divided by 12, nope. 45 divided by 8, nope. 45 divided by 6, nope. 45 divided by 4, nope. 45 divided by 3, yes. Remember that you want it to go in nicely without a decimal. That's why I said yes or no on the ones I said yes or no on. All right, let's look at E. I want you to take 27 and split it up. There's your start. And then you have to check all the numbers with 45 and 90. So just try E. Hopefully by now you figured out that 3 and 9 are the only two numbers that go into 27. Figure out which one works with both 45 and 90. All right, take a look at my calculator. 45 does not divide by 27 nicely, but 45 divided by 9 nicely. And then look, I didn't stop at that. I checked it with the 45 and with the 90. So it has to work for all three to be a greatest common factor. So my greatest common factor here would be 9. Side note that a couple of people will tell me that it is 3. 3 is a common factor, but not the greatest common factor. All right, let's hop over here to F. 18 is 1 times 18, 2 times 9, or 3 times 6. And I'm going to try 30 divided by 18. Nope. 30 divided by 9. Nope. 30 divided by 6. Yeah, it's 5. So 6 works with 30, but I still have to check 48. 48 divided by 6 is 8. Yep, that works. So my GCF is 6. Okay, let's talk about the variables really quick. So for a second, ignore the variables. 20 and 35 are the two numbers. 20 is 1 times 20, 2 times 10, or 4 times 5. 3 does not go into 20, neither does 6 or 7 or 8. All right, so 35 divided by 20 doesn't work. 35 divided by 10 doesn't work. 35 divided by 5 works. So part of my GCF is going to be the number 5. Then I want you to remember that x squared means x times x. And 35 has just one x with it. So what they have in common, or that's the same, is they both have an x. So there would be an x with that 5 as part of the greatest common factor. That's it. Okay, let's try h really quick. I'm going to go through the numbers a little bit faster since we've done several. Pick the smallest number. This time it's the 8. 8 is 1 times 8 or 2 times 4. If you pick the smallest number, it'll have a smaller list. Then I'm going to try 16 divided by 8. That worked. 12 divided by 8. Nope. So 8 doesn't work because it doesn't work for 12. 16 divided by 4. Yup. 12 divided by 4. Yup. So now they both work. 4 is part of my GCF. Then let's write our x's out above the problem. The 12 has 2 x's. The 16 has 3. And the 8 has 4. What do they all have in common? They all have 2 of them. See? So x squared actually gets to go on the GCF. Okay, it will always be the smallest exponent. And I know that sounds a little backwards because we're looking for the greatest common factor. The reason why it has to be the smallest is because the others don't have enough. So it'll always be the one that has the smallest, that is the most they all share in common. Which means if I look at this last one, wait, I don't even have to look at the exponents on this last one because the 24 doesn't have an x. And if the 24 doesn't have to have an x, then the GCF doesn't have an x. So I'm going to skip straight to my numbers. Let's start with the 18. 1 times 18, 2 times 9, 3 times 6. 24 divided by 18 doesn't work. 24 divided by 9 doesn't work. 24 divided by 6. There's 24 divided by 9. Sorry, I forgot to hit enter. 24 divided by 6 works. Double check. 30 divided by 6 also works. So my GCF on this one is just 6 because there's no x's on the others. So it's not that different to do the GCF with x's. You just have to think about how many do they all have in common. Okay, here's that whole bottom half if you need it. Go ahead and work on the assignment for the rest of class.